This lesson deals with supplemental problem 2.3. You can find this problem in the ECE302 ebook in the Chapter 2 supplemental problems, starting on page 5. We have a circuit with 2 ideal diodes, 2 resistors, and 2 batteries, but one of which we're going to vary the value of. Suppose that initially this is 3 volts. Can you find the voltage across and the current through each diode by guessing the states, and then verify until you find a consistent answer. Secondly, let's make Vn equal to 1 volt and try the same conditions again. Then lastly, what value of Vn will place the diode D1 at its transition point? In part A, we have a diode with an anode to cathode, and I've got a 3 volt battery here. If this is a practical problem, I would think that current would come out of the biggest battery and go into the smallest battery. I guess the current wants to flow this way and flow this way. Anode to cathode, I'll pick a short. Anode to cathode for diode 2, I'll also pick a short. That's my first guess. The current I1 coming in here is going to divide between these two, and let's find the current in here. It's going to be this node voltage of 3 minus this node voltage of 1.5. Divided by 1K is 1.5 milliamps. I know the voltage across this resistor, it's going to be 1.5 volts, so dividing that by the resistance of 470, I get 3.19 milliamps. The current flowing in here, leaving the node, would be the current that enters. And that's going to be I1 minus ID2. I1 minus ID2, and that'll be the current leaving the node, which is ID1. But that's a number less than 0, and so it's inconsistent. Since this one was contradicted, let's guess maybe this is an open circuit, and this is still a short circuit. Putting those guesses in, I'm going to guess that this is an open circuit. I'll have to find the voltage across it, and this is still going to be a short circuit and find the current through it. Label this as VD1 from anode to cathode, and current from anode to cathode for ID2. Find the voltage across this resistor, but now with just a voltage divider. I've got 470 ohms over 470 plus 1K times the 3 volts, and that's 959.2 millivolts. The voltage across this diode is going to be this node voltage, which is the 959.2 millivolts minus 1.5 volts. And that turns out to be a minus 540.8 millivolts, and that of course is less than or equal to 0. The current in diode 1, because it's an open circuit, is going to be 0, so we get that automatically. And then for diode 2, it's going to be a short circuit based on our guess. And let's find the current then in this diode, which is also the current in this resistor, but we know the voltage across it, so let's take that and divide it by 470, and that's 2.04 milliamps, and of course that's greater than or equal to 0, so those are consistent, and so the first diode is an open and the second is a short. Now what happens if we were to lower this voltage to 1 volt? Let's go back to the circuit on the previous page. Here's our largest battery, here's our smallest battery, so I would guess that current wants to flow from the largest to the smallest. But if that's the case, then this is going to be an open circuit. For D1, we have a battery here, and current could flow this way. I'm going to guess that D1 is an open and D2 is a short. And label the anode and cathode terminals, and likewise the current from anode to cathode. We could do this voltage divider of 470 over 1K plus 470, but now times 1 volt. The third is big, it's 319.7 millivolts. The voltage across diode 1 then is going to be this node voltage minus 1.5 volts, and that is negative 1.18. Current of course is 0 because it's an open circuit. Our guess here, the voltage would be equal to 0. And again, the current would just be the current in this resistor, which is the voltage, 319.7 millivolts divided by the resistance of 470. And that's 680.2 microamps. And of course that's greater than or equal to 0, so these guesses check. The third problem was to find the voltage Vn to put this diode at its transition point. So the transition point means no voltage and no current. If there's 0 volts here and no current here, there could be a path for current this way with Vn. Let's guess that D2 is again a short circuit. With 0 volts here, the voltage across this resistor is going to be 0 plus 1.5. 1.5 divided by 470 is 3.19 milliamps, and of course that's greater than or equal to 0, so that checks, and that's going to be also equal to our current I1 because there's no current going here. Now I can go around the loop. The rise in voltage is Vn, and the drop is going to be equal to the drop across the resistor, which is 3.19 milliamps times 1K, plus 0 and plus 1.5. And that turns out to be 4.69 volts. Whenever this input is greater than 4.69, diode 1 and diode 2 begin to conduct. In our previous examples, we were doing 3 volts and 1 volt. So there was the value of Vn if it was large enough to get both diodes to turn on. And this is supplemental problem 2.3.